Okay, now we're ready for Chapter 9. And what I think I'll do is I'll work one problem from each section of the 3 different types of problems that are described in your book. So we're going to start with Section 3, which is when you're hypothesizing about the population mean and you know the population standard deviation. Okay, so again, hypothesis testing is used to predict or to determine whether or not something that's been hypothesized about a population parameter, whether it be population mean or population proportion, which are the 2 in this chapter, to determine whether or not the hypothesis is either true or not true. So we're going to do problem number 18 in your book. And so this is on page 371. It says the average annual total return for the U.S. diversified equity mutual funds from 1999 to 2000 was 4.1%. So it's telling you the average returns of all mutual funds. So that's a population mean. So we know the population mean was equal to 4.1%. And the researcher would like to conduct a hypothesis test to see whether the returns for mid-cap growth funds over the same period are significantly different than the average of the U.S. equity funds. So it says formulate a hypothesis that can be used to determine whether the mean annual return of mid-cap growth funds differs from the mean for the U.S. diversified equity funds. So for part A, we need to create the hypothesis. So we're going to create the null hypothesis and the alternative hypothesis. And the thing I like to do is I always just like to ask myself, what am I trying to prove? And then go back and determine whether or not that is my null or my alternative. So in this one, it tells you you're trying to prove whether or not the mean is different than. So different than would be the same thing as not equal to. It doesn't say anything about more than or less than or at least or at most or anything. So we're trying to prove whether or not it's different than. So whether the mean is not equal to 4.1. So because that doesn't contain an equal sign, we can't use that as our null. We have to use that as our alternative. And we'll use whether or not the mean is equal to 4.1 as our null hypothesis. So remember, the alternative can never contain an equal sign. The null must always contain an equal sign. So first ask yourself, what do you want to prove? And then determine, is that going to be my alternative or is it going to be my null, depending on whether or not it has an equal to sign. Now the equal to sign can be greater than or equal to, less than or equal to, or just equal to. Okay, so that's part A. Part B says a sample of 40 mid-cap growth funds, so we know from that our sample size is 40, provides a mean return of 3.4, so we know our sample mean is 3.4. And then it says assume the population standard deviation is known to be 2%. So it's telling us a population standard deviation. So that tells us that we're doing this section of the book as compared to some of the other ones. It says use the sample results to compute the test statistic and the p-value for the hypothesis test. So whenever we know that the population standard deviation is given, we know we're going to be using a z-test. If this had been the sample standard deviation, then we would have used a t-test, which is the next section of the chapter. So once we know this, the formula to compute this, which is on page, just not sure if you guys know where it is, on page 358 in the little yellow box, is the sample mean minus the population mean divided by the standard error or the standard deviation of the sampling distribution. So we'll just plug in our numbers, 3.4 minus our population mean of 4.1 divided by the population standard deviation divided by the square root of the sample size. So when we do the math on that, it should come out to negative 2.21. Okay. So I'm going to stop there just so that the video won't be too long, and I'll start the next one.